Testing. We're going to be working some linear equations, and this subject here is intermediate algebra. Okay, so what is a linear equation? Well, I guess the best thing to do really is kind of give some examples first. If I had this equation, 5x is equal to 100. This is a linear equation, and the idea here is we want to solve for x in this problem. That is, find the solution that so when we plug it in for x, we get a true statement. And what we're going to do here is I'm going to multiply both sides by 1/5. 1/5 times 5 is 1, and 1 times x is just x. And so we're left with x is equal to, now 1/5 of 100 will be 20. So 20 is our solution. Now you notice we get another equation here. We started out with an equation and we end with an equation. But actually what we're looking for is what number can I plug in for x so that this makes us a true statement. So 5 times 20 is equal to 100. Let's look at some others. Okay, what about negative 3x is equal to 0. So we want to solve for x in this problem, and what we're going to do is I'm going to multiply both sides by negative 1/3. So negative 1/3 times negative 3 is 1. And a number times 0 is just 0. So as you can see, if I plug 0 back in up here, we end up getting a true statement. 0 is equal to 0. Alright, let's look at this one. 8x is equal to negative 144. So once again, I need to get a 1 in front of the x here, and I'm going to do that by multiplying by 1/8 to both sides. And of course, it doesn't matter whether I put the 1/8 on the left side of negative 144 over here on the right hand side. So 1/8, or an eighth times 8 is 1, and so we're left with x is equal to, we have a negative number times a positive number, and this ends up becoming a negative number, and that is negative 18. Alright. We have a negative 0.4 times x is equal to 14. So this time I'm going to multiply by a negative 1 over, this is its reciprocal, times negative 0, just rewriting. X is equal to 14 times negative 1 over 0.4. And of course, multiplying these two guys here together gives me x is equal to, and this here should end up becoming negative 35. So I just use the calculator and plug that in here. In this particular problem here, I'm going to go ahead and state the equation, and I'm going to give you the answer. It's going to be up to you to try to show that x is equal to 36. So work on that. Real quick hint, remember whatever you multiply 2/3 by, you want to make sure that you get a 1 here, right? A 1 times x. Okay. Hey, we're in intermediate algebra and we are looking at linear equations. Okay, so let me write out a linear equation here. We have negative 7 halves. In the last one, I just stated the equation and asked you to actually find the solution. So I hope you was able to do that. I think I actually gave you the solution and seeing if you can show how to get there. Okay, so this is similar to the last problem that we just did. What I'm going to do here is I'm going to go ahead and multiply both sides by negative 2/7, and I'm going to put parentheses around this because we're dealing with this negative sign. Negative 7 halves x is equal to negative 2/7 times negative 49. So we've got all these negatives we're dealing with here. So a negative number times a negative number is a positive number. All right. And we have 2/7 times 7 halves, that's its reciprocal. And what's going to happen here is the 2's are going to cancel out and the 7's are going to cancel out, and we're going to be left with just a 1. So once again we have 1 times x, but we don't write that, we just write x. Now we have a negative times a negative, so that's going to become positive. We can say that 7 goes into 49 7 times, so let me not skip too many steps here. So we're going to be left with 2 times 7. This 2 here, and then 7 goes into 49 7 times, and 2 times 7 is 14. So now we actually have a new equation here, but our solution is 14, and if we were to plug 14 in right here, this left-hand side should equal negative 49. Oh, let's look at another one here. So we got negative 7 times x minus 2 is equal to 12. So the first thing I'm going to do, we have a negative 2 here, a minus 2. I'm going to add 2 to both sides to get rid of this. So negative 7x minus 2 plus 2 is equal to 12 plus 2. And then we want to simplify this down. We have negative 7x is equal to 14. Now I'm going to multiply both sides by the reciprocal of negative 7, which is going to be negative 1 over 7. Negative 1 over 7. And that's going to leave us with x is equal to, now we have a positive number times a negative number, so that's going to be negative. And 7 goes into 14 2 times. So x is equal to negative 2. So our solution is negative 2, and if we were to plug it in up here in this equation, this side better be equal to 12. And I'm sure that it is. We have 0.2 x minus 1.31 is equal to 2.39. Whoops. What I'm going to do here is I'm going to go ahead and give you the solution, which is you should come up with 18.50. And I want you to try to show that x is equal to 18.50 once you manipulate this guy around. We are in intermediate algebra and we are working linear equations and finding solutions and having a good time. Well, hopefully anyway, we're having a good time. So let me write out an equation here. So as you can see, these problems should be getting more difficult as we go along. So we have negative 5x plus 7 is equal to 10x plus 11. What I want to do is I'm going to get the x's over to one side and all our constants over to the other side of the equal sign. And by doing that, I'm going to take, because I have a positive 10 as my coefficient in front of this x, and then I have a negative 5, what I'm going to end up doing here is I'm going to end up taking this negative 5 over here to the right-hand side, and then I'm going to take this 11 over to the left-hand side. And of course, by doing that, I'm going to add 5x to both sides. Okay, so now we have negative 5x, or we have a positive 5x minus 5x, so that's going to make that go away. So I'm left with 7 is equal to, I'm going to collect my like terms here, so that becomes a 15x, and then we have the plus 11. So now what I'm going to do is I'm going to subtract 11 from both sides. I've got to get this 11 over here to this side. So 7 minus 11 is equal to 15x. We have a plus 11, and then I'm going to subtract 11. So now I'm going to be left with, we have a 7 minus 11, so that becomes a negative 4, be their difference. And because we have a positive 11 and a minus 11, that goes away. That's what the whole idea of that was. And now what I'm going to do is I'm going to multiply both sides by the reciprocal of this 15. So 1 over 15 to both sides. And I always put a parentheses around my negative here. So now we're going to be left with x is negative 4 over 15. So we've manipulated this equation around down to its simplest form to this final equation here, but the solution is negative 4 over 15. If we were to plug this in up here in for x, which is something that you should probably do, you would see that the left-hand side will be equal to the right-hand side. So by saving some time, I've written this out already. So we want to solve for x in this problem, and what I'm going to do here is I'm going to get rid of this fractions. Okay, I'm going to get rid of this 5 and this 2 down here in the bottom, and I'm going to do that by multiplying through by 5. Okay, to every term in this equation. And so 5 times 1/5 is just 1, so we'd be left with x minus 5 times 4 is 20. 5 times 3 is 15, and 5 times a half just becomes 5 over 2 x. Now I'm going to multiply through by 2 to every term in this equation to get rid of this 2 down here in the bottom. So this becomes 2x minus 40 is equal to 2 times 15 is 30.